I'm here with something new, something more interesting, and something totally different from the other topics we have been discussing previously. So today I thought to discuss something about organometallic compounds. So I will tell you in my it's gonna be a very short lecture, so you will not get bored, because I don't want my viewers to get bored. So I'm going to briefly explain you what are organometallic compounds, and what are their properties, some of their properties I'm going to discuss, and their few applications. So I'm Professor Dr. Mchem from Dr.Mchem Institute of Chemistry. You can see my office, beautiful office that has got a very old time cupboard lying there, and with my box over it. So this is my office and I'm here. So I thought that I must share something with my students, because I don't want to waste time. So let's start. So what are organometallic compounds? Now these are the compounds simply with at least with one bond existing between a carbon and a metallic element, right? That simply relate to an organic molecule. Okay. So now there are metalloid elements. What are those? Like, for example, boron, silicone, and tin. They are referred as elements that can form these organometallic compounds. The bond that connects the metal and the carbon is covalent, right? Is covalent in nature. Now, if we discuss some of its properties, now these compounds are mostly solid state, right? Compounds. They are called as solid state compounds. That is, the compounds containing hydrocarbon groups that holds an aromatic character, or that contains at least a ring structure, that has got a ring structure in it, right? So this is one of the very important properties. The bond connecting simply the carbon atom and of course the metal is a very strongly you can say covalent in nature. It is a strong covalent bond. So those compounds that has electropositive metals, there are electropositive metals like, for example, lithium, sodium, both are electropositive. So they are volatile. They have the high volatility rate and can go through simply unforced or voluntary combustion, right? So the other one of the very important properties is that these volatile compounds can be very toxic for the humans, for all the living things around. And they can be used also as reducing agents. They are good reducing agents. So that is the ones that are established or devised by simply electropositive metals. Now these, we'll discuss few of its. I said, because I've just said that I will discuss few of the things, right? A few properties, few applications, and some knowledge about about the organometallic compounds. So now if I discuss some important applications, they can be used as homogeneous catalyst, especially in commercial chemical reactions, right? And they can be used as stoichiometric reagents, simply involving chemical reactions referring to industries, industrial side, not industries, industrial side. These can be also used as in the preparations of, or in preparing or in synthesizing semiconductors, in which these are the compounds like trimethyl gallium. It can be used as semiconductors. These are the compounds that can be used to make them, and triethyl antimony, right? These are used. They can also be used in producing the LEDs, right? And they can also be used as catalysts and reagents, especially when you are synthesizing an organic compound. They can, especially in the synthesis, in organic compound synthesis. And these, when we are referring to the complexes, their complexes helps in facilitating simply organic compounds preparations, right? They facilitate all organic compounds preparations that are related to it. So these are the few applications and few properties I have discussed. I will show you the structure of this organometallic compound, in which the two benzene rings are holding a metal in between them. So now I'm going to give you an example. I'm going to draw a structure of the simply organometallic compound in which carbon forming benzene molecule, it forms a bond with the chromium, right? So what does it would be like? I will show you in a minute. These are simply the carbons, right? And these are the hydrogens to it. It's basically the structure of C6H6, that is the benzene ring which I just showed you. C6H6, right? So what I'm going to do here is I'm going to draw simply chromium, 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 that is Cr, right? That is bonded again to simply with this. Another benzene ring. My drawing is not good. Benzene ring becomes a little bit, uneven from the side. So this is the benzene ring, the two benzene rings, and this is the atom, that is the chromium metal, the metal that is between them, right? This is the chromium metal. Okay, so now if you draw it here like this, I can show you how it's been bonded. Here also I can show you the same thing, right? But just to make you more clear, I can make a benzene ring structure, which you can simply see that how this carbon, it's like that. Now here this is chromium, this is the metal, it goes like that, and then right, so this is the other benzene ring, right? This is the delocalization of electrons, and this is simply going this way. So this is simply an example of this organometallic compound in which the carbon forming this benzene ring, right? Benzene ring, and when a molecule, it forms a bond with the chromium. You can simply see here. So this is one of the examples. So I hope you like this video. You have now understood what I meant by, and I explained you some of the the few of the properties. I explained you the applications, and I've explained you what are organometallic compounds. So hope to see you again with something more interesting and the continuation of these topics. Whatever I will find more interesting, more absorbing for you, I will definitely going to film it, and I'm going to explain it to you shortly. Thank you very much.